1.7 inequalities. These say solve the inequality, give the solution in interval notation. So that just means in like parentheses or brackets. We use parentheses if it's like just less than or just greater than. We use brackets if it's like or equal to. So 14, negative 3x minus 8 is less than or equal to 7. So we solve these just like we would in equality. So add the 8 over. So negative 3x is less than or equal to 15. So then I divide by the negative 3. Does anybody remember what happens when I divide by a negative?
Yeah, flip the sign.
Yep.
Or like whatever it's on.
Flip the inequality. So this becomes greater than or equal to, and then 15 divided by negative 3 would be negative 5. So this is greater than or equal to, so that means that x is anything bigger than or equal to negative 5. So this is going to be in interval notation, negative 5 to infinity. We include negative 5, and infinity, because it's not a set number, will always be a parentheses. So if it was negative infinity to something, the negative infinity would also be a parentheses every time, because it's not like something set. Um, 20. 2 minus 4x plus 5 times x minus 1 is less than negative 6 times x minus 2. So I would kind of just work on each side individually at the moment, and then we'll like combine everything the way it needs to be. So 2 minus 4x, and then distribute 5 times that. So plus 5x minus 5 is less than negative 6x plus 12. And so just to avoid having to write so much, I'm going to move the numbers over to the right and all the ones with the variable to the left, and go ahead and like combine them all in one step. So negative 4x plus 5x is x, and then add 6x, so that's going to be 7x on the left is less than 2 minus 5 is negative 3, so add that over here, so that's going to be 15. And then divide by 7, so x is less than 15 over 7. And I'm sure you've had teachers in the past that have been like, don't leave it improper. I personally would rather you just leave it improper. So this one, in interval notation, x is less than 15 over 7. So it's just less than, so that means it's going to be a parentheses. So this is going to be negative infinity to 15 over 7, and it's a parentheses there because it's just less than. So for these to be completely right, you need to make sure you solve it and then also give the answer in this interval notation.
Would it not be a bracket?
No, because it's just less than.
Oh, yeah.
If it has the or equal to, so if it has a line under it, then that's when it's a bracket. So you can kind of think like the line means like a straight line for a bracket. So we can also have like a compound inequality. So something like these all basically, they break them up into sections, but they all basically say solve the inequality and write the answer in interval notation. So 32, we have negative 6 is less than or equal to 6x plus 3 is less than or equal to 21. So basically what's going to happen with these is that we're going to end up with basically 2 endpoints instead of one of them being at infinity. So when we do something and we're like moving stuff out of the middle, because I'm trying to get x by itself, I have to move it on both sides. A lot of times people get confused and are like, well, I just feel like subtracting 3 from -6, and they don't also do it from 21. So make sure you do it from both. So -6 minus 3 is going to be -9. Is less than or equal to 6x is less than or equal to 21 minus 3 is 18. And then we would divide by 6. So that's going to be -9/6, which I will reduce in a second, is less than or equal to x is less than or equal to 18 divided by 6 is 3. And then just need to reduce this one. So this is going to be -3/2. It's less than or equal to x is less than or equal to 3. So now x has to be between -3/2 and 3. So, and because it's or equal to, we're going to bracket both of them. And so it's going to be bracket -3/2 to 3, and then close the bracket. Now, sometimes one of them may be a bracket and the other one may be a parentheses. It's all dependent on whatever the inequality that you were given is. Okay. Also, the rule still applies if we divide or multiply by a negative, then we flip both inequalities, not just the one. So, just make sure you do that. Let's see. 36. -5 is less than or equal to x minus 3/3, less than or equal to 1. So what would I do first with this one?
Multiply by 3.
Yep, multiply all of it by 3, so that's going to give me -15 is less than or equal to x minus 3 is less than or equal to 3. And now what? Add 3, so -12 is less than or equal to x is less than or equal to 6. And so brackets or parentheses or a mix of the two. Yep, brackets from -12 to 6.
And then infinite is
always a parentheses.
parentheses.
Yep, because it's not set. So basically, if it's set, then we use a bracket. Okay, let's see. So these next ones are quadratic inequalities. So basically they're quadratic equations that are set as greater than or equal to or greater than whatever less than some number. So something like 40, we've got x squared minus 7x plus 10 is greater than 0. So these kind of work the same way as the equalities that we did recently. Basically, we're going to factor them and then set each piece as greater than or less than or whatever 0. So we still kind of use like the zero product properties, something like that, to do it. If there was a number over here instead of 0, I would need to move it over before I factor. But what factors of 10 give me -7?
-5 and -2.
Yep, so x minus 5 and x minus 2 greater than 0. And then I'm going to split it and do each piece greater than 0. So x minus 5 greater than 0, x minus 2 greater than 0. So then x is greater than 5, x is greater than 2. Now, it still wants my answer in interval notation. Okay. So, with this one, both of them say x has to be greater than something. Okay. And so, if we were to plug in, let's say, 3, we need to find out if it's going to be greater than 0. Okay. Because we're going to go with whichever thing is stricter. Okay, so if I were to plug in 3 up here, I would end up with 3 squared, and I chose 3 just because it's between 5 and 2. So 3 squared minus 7 times 3 plus 10, and it needs to be greater than 0. So 9 minus 21 plus 10, so that's going to be 19 minus 21, which is negative 2, which is not greater than 0. So that tells me right there that this one is not going to work. Okay, so my stricter option is for x to be greater than 5. So my solution would be, because it's just greater than, it would be a parentheses from 5 to infinity. Let's see. Let's do 44. This one has something interesting about it. Negative x squared minus 6x minus 16 is greater than negative 8. All right, what do you notice about all these numbers? They're all negative, so any idea something I could do?
Can you make them all positive?
Yep, so I can divide by a negative across both sides. Now, what does that mean I'm going to have to do? With inequalities, what happens when I multiply or divide by a negative?
Oh, yes, switch the sign.
Yep, so I'm going to basically, because everything is negative, I'm going to take out a negative and remove it all together. So this is going to become x squared plus 6x plus 16 is less than, okay, because we had to flip it, 8. So basically, without writing it, what we did is we took a negative out of the left and then divided negative 8 by negative 1. But we don't need to do that because we can just visually see it and take it out. So now I need to move the 8 over because I need it to be, I'm going to say equal to 0, but in this case less than 0. And so I'm going to subtract the 8 over, so that's going to give me x squared plus 6x plus 8 is less than 0. So now I need factors of 8 that add up to give me 6. Yep. X plus 2 and x plus 4 less than 0. So now each piece less than 0, so x plus 2 is less than 0, x plus 4 is less than 0. So x is less than negative 2, x is less than negative 4. So now, again, I need to see which one is basically stricter, okay? So I'm going to choose negative 3 because it's between the two, okay? So with the other one, what happened was they both were greater than a certain number, but I needed the one that was the most greater than, basically, because the other one caused a problem. It didn't give me an accurate value. So down here, more than likely, Because this is reverse and it's less than, I'm looking for the one that's the least negative. But we always want to check and make sure. So I'm going to use -3 because it's between them. And if it works, then I'll know that it needs to be -2. If it doesn't work, then I'll know it needs to be the -4 one. So, and it's always going in the original. So, let's see, negative, and then in parentheses, -3 squared minus 6 times -3 minus 16 is greater than -8. So this is going to be, the -3 squared is going to become +9, but it's negative because of the negative out front. So -9 plus 18 minus 16. So then that's negative, yep, thanks. -7 is greater than -8, which that is true. Okay, -7 is closer to 0. So that means that I'm going with the -2 option. So oh, wait a second. Hold on. Oh wait, -7 is greater than -8, which is true. So I need to check something outside of that range also and make sure. So I'm going to check -5 also, because it's possible that it could only work between that range. So I want to make sure that that's the case. If it had caused a problem, it would have been different. But because it worked, now I need to check something outside of the range of that. So I'm going to check -5. So negative times -5 squared minus 6 times -5 minus 16 is greater than -8. So it's going to be -25 plus 30 minus 16 is greater than -8. What's that? 5 minus that. So that's -11 is greater than -8, which is not true. So this actually is going to be between -2 and -4 is actually where it's going to work. Okay? Because outside of that range, it doesn't. Because -4 is basically the lowest I can go and it still work. But I can't include -4, so it would be like -3.99999. So this one is actually, it's kind of a weird one. It's actually going to be from -4 to -2. Because if we did -1, it also wouldn't work. So it's got to be in between that. Or if we did 0, 0 doesn't work because that would be -16 is greater than -8, which isn't true. So I know I've got to be within between those numbers. Most of them won't be that complicated, though, to like think about. All right, 2 more and then we'll be done. Solve each rational inequality. So it's basically giving you an inequality as a fraction and give the solution set an interval notation. So 58, 6 minus x over x plus 2 is greater than 1.
You have to multiply by, what would you multiply x plus 2?
So I want to basically try to eliminate the fraction, so I'm going to multiply by x plus 2. So I'll be left with 6 minus x is greater than, since it's 1 times x plus 2, I'm just going to write it as x plus 2. And then I need x is on one side, numbers on the other, so move the x to the left. I've got -2x is greater than, subtract 6, -4. Divide by the -2, so I need to flip the inequality, so x is less than +2. And the nice thing is, I don't need to really check anything with this one. Well, I say that. What can I not have when I have a fraction? Something about the denominator. Can't be 0. Okay, that still applies with these. So I've got to also eliminate that. Okay, so what number would make that 0 on the bottom?
0.
-2. -2 plus 2 would be 0. So I would also need to do this. Cannot be equal to 0, so x equals -2. Okay, more just showing you for the work purpose. So I need to eliminate that. So when I do my answer, these ones are going to be written a little differently. We would have, it's less than, so -infinity to -2. And then, and it's not including, because if we have -2, it causes a problem.
Oh, was that the thing that we did in the first chapter?
Union, yep. And then -2 to 2. Okay, and then it's a parentheses again because it's just less than. And we do that because, again, we can't have 0 in the denominator because it becomes undefined, and it's got to be less than 2. So we're basically eliminating 2, and or anything greater than 2, and we're eliminating -2 because it causes a problem.
Will those be on the test? That kind of.
It could be.
Are we gonna have to answer it like that?
Yes. It says it has to be an interval notation.
I just don't like that you. I hate you.
No, last year I never knew how to do the yeah, how to answer it.
Honestly, if you just told me it was less than 2, I probably wouldn't be inclined to take off that much for it because a lot of people with these don't think to look at it. But we still can't ever have 0 in a denominator. So we're technically supposed to remove it. But like the next one that we're going to do, I'll show you how it technically should be written, but how most people end up writing it. And then we'll go from there. 74 over x plus 1 is less than 2 over x plus 3. So you've probably seen this type of problem before as an equality. And there's some special thing that we do with these, but I don't know if you'll remember what it is. None of y'all had the teacher that I had that would have given you this hint, so you might not recognize it.
But x plus 1 on that side and x plus 3 on that side? Or something like that?
What's the
I feel like I remember doing that last year.
Be the pretzel.
Oh, okay. So you do 4x plus 12, and then it would be 2x plus 2.
4x plus 12?
Yeah, right?
Yes.
How do you get 4x plus 12?
Because you gotta do the pencil.
All right.
Oh, you just, the butterfly.
So you had my mom. Maybe my mom does it too. Did my mom tell you that?
What?
Be the pretzel? Or do you
Yeah.
know that from somewhere else? Okay. So
She says that a lot, actually.
when I had the teacher that I had, and she taught us that, she said once you get to Mr. Cass, like in Algebra 2, she was like, don't say be the pretzel, because he's going to look at you like you're crazy, because he wants the mathematical term, which is to cross multiply. But be the pretzel is the way I remember it, because when you draw it, it kind of looks like a pretzel from,
They always said butterfly because you circle.
That does not look like a butterfly.
No, if you circle x plus 3 and 4.
Why would you
Or
circle
an x
it?
plus 1 and 2.
Are you talking about this?
Yeah, the butterfly.
That looks like an X of fat.
Oh yeah, add a little thing in the
Or
middle.
two band-aids that go over each other.
Put our methods together, and we've got some really long antennas on a butterfly.
It's a band-aid.
It's a butterfly Band-Aid.
Yeah. Called a butterfly band-aid.
Exactly.
I feel like it's mass chaos, but I'm going to leave it because why not? Got to have a good memory from the class, right? So it's 4 whoa, come back. Hello. It is 4 times x plus 3 is less than 2 times x plus 1. So then this gives us 4x plus 12 is less than 2x plus 2. So 2x is less than negative 10. So x is less than negative 5.
We have to rule out the 0 again.
We really should. Now, this is the way that they typically will write this answer. You're typically going to see the answer as negative infinity to negative 5. But we should be concerned about the stuff that makes it 0, which would be what?
Negative 1.
And
negative 3.
so technically, oh wait, this one's a little different. Is negative 1 or negative 3 in this interval? So we should be concerned about this and this, but I only care about this if they're in this interval.
Oh, wait, yeah, wait.
Because
Negative infinity would be negative 3.
No, that'd be like negative 47 to negative 5, which is not.
Yeah. Negative 3 would be over here somewhere.
Oh, yeah.
And so would negative 1. So that's actually outside my interval. So yes, I do care about it, but because it's not listed in my interval, I don't have to do anything special.
Yay.
If it had been, then I would have been unioning like multiple things together.
We don't like that.
No, we don't. It's a lot more effort. All right. Any questions about any of this? You're okay for now? All right. 13, 19, 31, 37, 43, 59, and 69.